Good evening.
Hey, good evening, Nathan. How's life?
Good. How about you?
Yeah, going on. Hey, Stan and Aditya, welcome.
Hello, everyone. Morning.
Morning/evening.
Good day is better.
I know. Let's give another 4 minutes. I'm actually setting up the other machine here.
Front, right, front, left.
Hey, welcome everyone. I am actually in the process of finishing the setup of the new machine. Ta-da! Okay, so let me start.
Good morning, all.
Hey, Hema?
I said
Good
good morning
good
to
morning. Good
everybody.
evening.
Okay, yeah. Let us greet ourselves. We are 2 minutes into this thing. And quickly, what I want to share with you is a couple of things, because I don't know, like some of you might not have joined Thursday, Friday. So there are 2 important updates I want to share. The first one is on the first machine, we set up a remote machine and we connected, and we set up tail scale and all. Okay, let me share my screen here. Okay, so this is the machine. Tails. Oh yeah, because I exposed this machine to the internet, I secured this password. Okay, this is awesome. Continue. This is what I was working on. Okay, so this is one, and we also have another one. Let us call top 10 countries by area. Okay, this is going to be slow because, okay, in summary, let me update this summary and we will start from there. There are 2 things we did. Last week, we set up this Llama server, which is up and running on a laptop which had 3 GB of, 4 GB of VRAM. Okay, so this laptop has got 30 GB of RAM and 4 GB of VRAM, and on this one we have set up this. Okay, This is what we did last Friday. We did this Llama server up and running, and we as we had less memory, we have to add only NGL 10% of GPU. Okay, and if you look at NVIDIA SMI, so this is using 3.6 GB out of 4 GB. Like we are nearly full. This is what we did, and I also gave access to some of you. Okay, and I only had less number of licenses, so I only allowed like 6 of you to log in. Okay, so now Uma, you are not logged in yet. Somebody was telling me, oh Uma, you are here. So Uma, you said you want me to remove this thing, or I was not very clear.
No, there should be only one UMA laptop. I don't know if you're able to see the device name, right?
I
I
Only
had
this much I
logged
see.
in cell phone and the old Chrome OS. But we're seeing only one UMA now.
Correct.
We're not seeing three.
I don't think I ever.
Oh,
Okay, because I also had limited number of users here, so I stopped it. Okay, so and then last week we saw Yuvraj was able to access this machine both from the browser and both from the SSH, and he could log in and do whatever he wants to do. So this is what we did it on Friday. So we have a machine, we have installed a model, and we are also serving a model. This is painfully slow because we are already using 3.8 GB. Okay, it is working, but slow. And I have some good news. So what I did is, as I might have shown you already, I actually had another server. Do you all see the server here?
Yes.
Yeah.
Yeah. And this server, I actually bought a used one, which is 8 GB, right? And this is what I've set up. 3 GB is insufficient. I agree. So I bought one. I mean, today, like a couple of hours ago, I went to this website called Kijiji, which is like where you can buy all used and old stuff. And ta-da! I have a machine here, Z820, NVIDIA-SMI. Okay, I have 8 GB of VRAM running here, and I already have a model which is consuming 2.7 GB only. So if I give you access to each one of you, at least 3 of you can run 3 models in parallel from scratch on this 8 GB, each like 2.5 GB ish if you can use. Okay. And it took me 15 minutes, and I have step-by-step documentation. So my plan today for each one of you is, you have to log into the server or the old server for whomever I gave access last week. You have to come here and set up 2 things. Okay. And the 2 things are, one is Llama CPP, which I have already set up. So you use Llama CPP to download and install any small model you want. Hey, Rafael, welcome. Okay. Hey, Rafael, last week what we did is on Friday, we set up Llama CPP, and we got it running. And in addition to that, I set up another 8 GB server, which is sitting behind me, and I'm running Llama server and also OpenWeb UI to serve this thing. So these are the 2 components. So my plan, today's action is, maybe you can become like 2 batches of people, at least 1 or 2 batches of you has to form today, and log into either of those machines and download any model, small, obviously, latest and small, and run it using Llama CPP. That you have to do today. And extra thing is, I'm serving it using Open Web UI. Okay, maybe I'll show you a demo of this in the next few minutes whenever I get this remote working. Okay, so I'll show you a demo of a few minutes, or 30 minutes at maximum, and after that we have remaining time. You have to get your hands dirty and download any LLM, whatever you want, and run it, and also use Open Web UI to run it. Okay, so that is today's plan in a high level. Okay, so now before I even get into that part, I want to ensure that one of you has to come here and then show us a demo or whatever, how it is using. And I want a volunteer from one of these people here who can connect remotely both SSH and from a browser, and at least stop and start this server. Okay, so who is ready now to share your screen and then do all this activity? Because I believe Yuvraj did this on Friday. Yuvraj, are you willing to share us your screen and show us what you can see and stuff?
Yes, Jay.
Super, thank you. And anybody else here who did some work on whatever you can see also? Who else can do this in addition to Yuvraj? CP, you can do it? Okay,
I can do it.
super. So Yuvraj, we already saw that you confirmed it. I want to give a chance to CP.
Okay.
Okay, and obviously if you cannot, then you surely do it. CP, go ahead, start your screen, and then shows the SSH, and then how you logged in and what you see, and open in another browser the browser-based interface of whatever this is, and show us how it works. Go ahead, you can share us your screen. I'll stop sharing. As that is happening, let me try to connect remotely. Yeah, okay, this is your, no, CP, I want to see your full screen, including the browser URL.
Okay.
Share full screen, and also show us the SSH command also, please. Okay, fine. And Ministral is running. Okay, ask any question, like which country has got like 10th largest lakes? Some random question, whatever comes to your heart. Go ahead. Okay. Can somebody fact check this by actually going to Wikipedia or somewhere else?
This data is as of October 2023.
Whatever, but these
This
things
is
won't
correct.
change, right?
This is
Hey
correct.
Sanjay, welcome.
Hello.
Yeah. Okay. Hey Sanjay, quick update. I have two machines running. That laptop which you saw with Llama CPP. Wait a second, let me confirm. Is it Llama CPP? I think so. I'll reconfirm.
This
And
is Llama,
sorry.
this UI is Llama CPP, I believe.
Oh wow.
Yeah, you should not be using Llama CPP as your normal chat UI. It's very much a ultra simplistic thing, but it's like a good testing bed. It's like a good test bed for like, hey, do these model settings work and whatnot.
Good point. So that is on last Friday. Today, what I did is I'll steal your screen for 1 minute, okay?
Okay.
So Sanjay, today what I did is, you saw that other server?
Yeah.
You see my screen here?
Yeah.
Ta-da! I have 8
Sure.
GB running and I have Llama CPP server running.
Okay.
And
You should be using a bigger model for this. If you have 8 GB, try
wait,
running
sir,
Gemini E4B.
we are 10 people. All of us want to download and install multiple, okay? I'm happy with 2.7 GB. One thing.
Sure.
And the second thing is, I'm also running Open Web UI.
Okay.
That's better than Llama CPP, right? When it comes
Open Web UI is like an actually good UI that's like meant to be used. Yeah.
right. So it is a good thing to master Open Web UI in the next couple of days, right?
There's no need to master it. It's just software you download, install, and use.
For us, okay, we are learners. Okay, wait. Sudo docker ps. Yeah, you see this Open Web UI. I know it is a single command. I got it, but then there is so many configurations. Okay.
Yeah.
And fine tuning. That's what I said. It's going to take us for a day. Okay.
Yeah.
And this is our plan today. That and I have Tailscale, which is running on this one server where 6 of us are connecting and using.
Okay.
Where is my Tailscale? Yeah. So if you see here, I have Tailscale, as you saw, like only 6 of us can do this. And on the server, I logged in as another user, and I'm going to give access to 6 of them.
Yeah.
So they can connect to this larger box with 8 GB of VRAM and 64 GB of RAM, and they can run and run in parallel and learn. Okay.
Yeah.
So as you're here, I just want to connect to that machine and then show you the Open Web UI, and you tell us what else we can do. Okay.
I mean, primarily the thing that should take the most time for you is setting up the proper model settings on Llama CPP and figuring out what settings exist and whatnot.
Wait a second. What do you... So, but then using Open Web UI, can't I fine tune?
No. This is like command line options for Llama CPP.
Okay, super. So then look.
Like obviously, sure, spend your day doing Open Web UI. That's cool, whatever. But the thing that should take you the most time is understanding what the settings Llama CPP are for like model inference specifically. I don't care about the web server settings and whatnot. So, but like the model inference settings and like, hey, what does temperature do? What does NGL is simple, but like, what does temperature do? What does -c, the context do? What does...
Wait a second. Wait. Is there any GUI interface for that or not for the Llama CPP server?
No.
Okay. No. Okay, wait a second. Let us go back to this guy here. And
like obviously spend your day on Open Web UI. It's like, sure, whatever. It's like it's nice software, but
yeah, for sure. And we need to master that anyway, but that is step 2.
You don't need to master it.
What? Why?
It's like software that you just use and you set up and you don't worry about it. You don't need to master it. It's the other parts of the thing that you need to put effort into mastering.
Okay. So then let me ask you this question. Now here, can't I configure Llama CPP from here?
No.
No, is it?
No.
Nothing much. But I saw, like, then what?
Look at sampling. Look at what the thing in sampling lets you do.
Sampling, yeah. Yeah.
Are you able to?
Yeah.
Are you able to actually edit any of these?
Yeah.
I assume
default. No. Okay. Temperature. Tell me how much you want to put. Default is 0.8. So should I put 0.5 and save this?
Try setting it to like 35 and then seeing if it like breaks the model to see if it actually edits it.
Like 35? 3.35.
No, 35. 35. 35.
How much was the
The
old
model is going to
value?
be incoherent. The model is going to be incoherent. This is
Okay.
a smoke test.
So if I put 35, this is going to become mad now?
Yes. Save settings and then see if it actually becomes mad.
Okay.
Then it's you're doing pass through into Llama CPP, in which case you're good to go. You're free.
Sorry.
I don't think. No, this is actually pretty. Yeah, no, this checks out. This checks out. This is with different. Yep. This is with insane. Oh, but this is Ministral 3. No, this is fine. This is fine.
Right?
Yeah. Okay. Try saying temperature 0 and see if it becomes deterministic.
Okay. Sampling temperature is 0.
Yeah, if you set temperature 0,
Yeah.
it becomes deterministic. So just ask a question and
Like
then just try rerunning it a few times. It doesn't matter. I'm showing off how the models work. The question you asked does not matter here.
okay, that's possible. Now what
Okay.
do you want me to ask?
Rerun it. Rerun it.
Just same question?
Same question. Rerun it. No, just press the retry button here. There's a retry button
So
in the
this guy
bottom.
here?
Yes.
Okay.
If you see the exact same token
Regenerate.
layout,
Regenerate. Okay.
Yes. Okay, so these settings do transfer over. Okay, that's cool. That's new. Okay, so you can just use that UI. Great. So you should go to the UI thing there.
Yeah. But wait a second. So it is repeating the same answer exactly.
It's temperature 0, so it's deterministic, fully deterministic.
I see. Okay. So temperature is 0 now. So if I ask the same question, it should answer the same thing?
Not this way, because this was generated with temperature 0.8. If you ask it now, it will generate something. If you ask it again with the same exact text,
I see.
it will generate the same thing there. Because if
Okay.
you set the temperature higher, that increases the randomness. Right? So if you think about what this is actually doing,
Yeah.
the LM only outputs a probability. Not a probability, it outputs something called a logit. Okay? Temperature is the sampling function of logit. So say like the top token is like 20, the 10 token is 5, and then whatnot.
Yeah.
And then the process of sampling that requires you to have a temperature value to figure out the probability of how much weighting you give to the higher numbers or the smaller numbers.
Mm-hmm.
And so because of that, if you increase the temperature, you're effectively increasing the probability of the less likely, of like the less like highly valued outcomes.
Mm-hmm.
But if you set the temperature to 0, you're effectively saying just give me the highest one always.
Okay. Fine. So now let us continue the journey. Setting and sampling. Okay.
So
wait.
this is a different tab.
Why did not it save it?
It's saved per tab.
Per tab?
Well, not per tab, but like it's cookies. It's on your local. It's saved on your local end. It's not saved on your.
Okay. It is saved. Okay. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So there is
This is not everything.
I know. Wait a second.
Yes.
So these are all top 10. Okay. Now, if
XTC is not part of the top 10. I didn't see top K in there. You want to know about top K? Top K sampling is very helpful. Go back to your browser. Yeah.
Yeah.
I didn't see top K. I didn't see MinP is there. I didn't see.
Hey, top K. Wait. Yeah.
Top K. Okay, hold on. Scroll down slowly. We got top K. We got top P. Sure. We got MinP. That's good. XTC and XTC threshold are like not super useful, but sure. Typical P is not super useful, but sure. There's nothing here on MTP because MTP requires some more stuff. With
MCP, you mean?
MTP. Multiple token prediction.
Oh, I see.
What you do is you have a big model and a small model that's been trained on the big model. And so
Okay.
you have a small model,
Mm.
generate like 30 tokens.
Mm.
Probably not 30, probably like 3. But like you get to generate like n number of multiple tokens, and you get the big model to effectively verify that yes, this is what the big model would generate.
I see.
So this way you can get like 2x, 3x speed up on your models at the cost of like a marginal amount increased VRAM.
I see. I see. Okay.
Not every model supports this. However,
Yeah.
the ones that do, it's like 3x speed up. It's pretty good.
No, no. Okay, one second. Man. Where is Llama server?
You set it up.
I know. Give me
Yeah.
a minute. Local only. Mm.
Build. Bin.
Okay. Now / llama. Sorry, what's the name? Llama server.
Yeah, Llama server.
-h. Okay. Now these are all the things you are supposed to know, right?
Know about, yes. Does this contain everything?
Oh my God,
Yeah,
this is
it
too
contains
big.
everything.
Look, I just keep on giving. Oh my God, look
Yep.
how much this is, right?
Yep.
So these are all the knobs I have to manage
Yes.
this Llama server. So if
Yes.
I have to optimize this to the maximum extent, right? By knowing as a sysadmin also, right? I need to
Yes.
know what each one of these do. Top P, min P.
And those are the ones that were shown in the like UI. But there's
Yeah. So around 10 of them were shown in the UI, but looks like there's 100 more.
yeah, spec drafts, that's the MTP. You have well, you can enable
Hey, model max n.
maximum number of models to load simultaneously. So this way, if you're running like let's say you have running a server and you want like 24 people to access it or whatever.
Yeah.
You can be like, hey, I want to set the maximum number you can load to 24, so that we can like maximize, because it will load like as much as needed if it has enough demand, like pings towards it or whatever.
Okay.
And so especially if you're doing stuff like splitting it across multiple GPUs. Well,
hey Sanjay, let us do one thing
Yes.
then. Do you have another 20 minutes for us now?
You see above, you see -S metrics. You can enable Prometheus compatible.
Wait. You have another 20 minutes for us?
Yeah, I have time.
Thank you. So then let us please speak about whatever interests you, like 1 sentence, 2, 3 sentences of all these things one by one here. And then let us go to the command line. Let us browse it. And whatever comes to your mind is interesting, please share with us, okay?
Sure.
For the next 20, 30 minutes. Let's go one by one and explain like we are 15. Okay.
Okay, sure. Yeah.
And one quick question. Hey, is everybody okay with this plan for the next 20, 30 minutes? Because I mean, when you are serving the model, what are all the knobs we have to turn, how to optimize is the thing we need to do. And that we have to master. We just can't just serve the model with the default values. It is not going to work in production.
I mean, defaults are good, that they'll get you 80% of the way there. But
Correct.
You can save 20% of your money on cloud spend if it's in the cloud by optimizing this.
And also the use case is going to be unique, right? Like my company, it might be use case.
Yeah.
Aditya, I thought of telling 5-year-old, but then Sanjay, Aditya want to explain to 5-year-old. 15-year-old is okay, I think, for us. Okay, let's go.
Okay.
So what is temperature?
So to do this, I have to explain sampling. So for that, I'm going to share my screen.
Oh, please, I'll stop. Yeah, go ahead.
Yes. Yeah, share my screen. Sure, share my entire screen. Okay, you can see this software, right? Let me mute the tab.
Yes.
This is just a simple web thing. So you have your model, right?
Yeah.
You have your model. The model is going to output a list of tokens, right? So it's going to so you guys get a list of numbers. So let's say 1.5, 1, 0.5, 0.2, 0.1, right? And these are your token outputs, right? So like this is going to be like what, when, who, whatever. These are your tokens that it's predicting, right?
Okay. Yeah.
Then this goes into a function called softmax.
Okay.
This is the most common one. There's other options, but softmax is the most common one. And softmax turns this into a probability percentage, right? So it says this 1.5, let's say that's 0.3, then 0.2, then 0.1. It effectively turns into like a number between 0 and 1. That's your percentage. And then you sample it by effectively just picking a random number based on this probability. Softmax is effectively doing some exponential stuff, and this is where temperature comes in. Okay? So if you set temperature, let's say this is temperature 1. Right? This is temperature 1. If you set T equals 0, you're going to get something that goes 1, 0, 0, 0, where this is the only thing. It's 100% probability. Okay? So this is T equals 0. And then if you set T to arbitrary high numbers, like let's say infinity, you're going to get all having like an equal probability. 0.1, 0.1, 0.1, whatever. Right? And so you changing the temperature T changes how likely the less likely tokens that the model predicts will come up. Okay, so that's what temperature does.
1 second. So now, like Claude and all other people like publicly serving. So will they serve? I mean, set a fixed temperature, or it is based on the user?
You can set temperature with all those providers.
As a user.
As a user, yes.
But obviously, we don't even know that it exists, okay? 90% of people don't even know I can set my own temperature.
Yeah.
So in that case, what temperature will they set?
It depends on the model. Different models have different temperatures that they like. So something like OpenAI models, apparently they like higher temperatures. So like some of the people doing stuff.
So it is not customized based on me?
It can be.
Okay.
It's a mix of what the model performs best at, as well as what you need for your use case.
No. Won't OpenAI know this is J? Let us set the temperature. This one. This
No,
is.
they don't do that. They don't do that.
They don't?
For any like personal use case in like ChatGPT.com or like Codex or whatever, they set it to a standard. I think 1.1, 1.2.
But that is inefficient, right? It has to set based on the customer. When I log in, it knows me.
It's the same amount of compute.
But
and so what they do is they set it at the optimal point for the model.
No, Sanjay. Look, if let's say I'm an IT person, I'm always asking technical questions and codes and script. It should be closer to truth. Let us assume there is another guy who is an artist or studying some artistic creative literature. For that guy, they should know, okay, this guy is asking literature, let me be creative, right?
That stuff for these more modern models, it like doesn't really matter.
I see. Okay, please go
because the most you're changing is like 0.1 either way, and at that point it's like why? Just keep it like standard amount. Because the thing is, like obviously if you like, let's say you're like an autistic person, but then you want to ask about like what the like stock price or something is today. You don't want any temperature there. Right? And because people can ask about many different things, they set it to one standard that's like best for the model, not knowing anything about the question. Whereas if you're at a company and you're like, okay, the only people using this are people using it for like document like retrieval or whatever, you want that to be accurate. You set that temperature lower.
Okay.
Right? But obviously not so low that the thinking traces of the model become constant, so that you it performs worse. So you need to like make sure there's like a minimum amount, but that changes model to model. So you have to like test it on your own eval.
Super. Okay. Thank you. And in summary, like entropy, if I keep the temperature higher, it is going to be more artistic and random. If I keep the temperature the lowest, then it is frozen and focused and based on facts.
Yes, that's why it's called temperature. This is actually fun fact, the naming behind it.
Entropy. They could have called entropy itself.
Technically, entropy is a slightly different thing.
Okay.
But yeah.
Sure. Okay.
Cool. Stop. Cool. What's next? What's next on that list?
Sure. And you are not using Dra.io yet, or even Excalibur, or whatever the other.
Well, this is just some random web thing.
Okay, 1 second.
Yeah. So should they ask in Gemini, does Flash and Pro are they the same temperature? Probably not.
Okay.
Google's going to set the temperature based on what they believe is best for the model.
I
So,
see. Okay.
Flash models, because they tend to be a lot faster, and the goal is to be a little bit cheaper, they tend to they're probably going to set the temperature to be a little bit lower. Whereas with Pro, because they think longer, they want higher temperature for that.
Okay. And also, Sanjay, only go through what interests you, because there's so many things we have to cover. Which one you want to talk next?
Dynamic temperature, that's only chat UI type stuff. We can kind of ignore that.
Okay.
Another question from Audit here: is it recommended to keep switching temperatures amidst the session? It depends on the session. If obviously the perfect possible temperature for a query will change as the session goes through, but that's a lot of added work to do while you're doing the stuff, and you're going to have to look at what the session is and whatnot. What might make sense is if you have a low temperature for the first query that you asked, and you increase the temperature for further ones. That's probably the most I'd recommend doing. But at that point, it's there's probably other optimizations you can spend effort making.
Okay. Sanjay, Shruti has got another question.
Yes.
The question is, in Gemini...
I already answered that.
Is it?
That.
Okay.
Yeah, it's different per model.
Okay. Super.
Yeah.
All good now?
Yes. Then top K. So top K is really good. What top K is it effectively makes it so that it only does softmax on the N on the K. The K most likely tokens. Right?
Okay. That is technical explanation. Now, if you want to come back to explain M5, how do you say this?
Top K allows you to increase temperature to have theoretically you can search the space more often while removing the possibility of those really crazy whack situations. And so you want to set a top K. Default of 40 is pretty good, but depending on what you're doing, you might want to set it lower to 10. Or sometimes I've seen people have pretty good results with 5. Right?
Hey, you know what? Wait a second.
Yes.
Maybe later we should take the case study. Okay, we have CP Rail, Husky Energy, and let us say Canadian Tire and Sport Check, and let us say Shah, both their video streaming technology team and their let us say ISP team and a mobile phone company. So these companies, should they consider all these 100 parameters and then fine tune them based on their requirement?
You probably have at least one person who knows what they're doing with these. Yeah.
Hey Sanjay, we are that person. Okay, all 15 of us over here, we are that person.
Yeah.
No. So based on the customer and their profile and then what they require, we have to fine tune these 100 parameters, right?
Don't use the word fine tuning here, but you have to
optimize these parameters.
Yes.
Correct. And give me settings. Okay. Give me one example for these 4 companies where I said, give me only one use case where it is going to be completely different for any of these parameters.
Okay. So let's say you're an engineer who wants to
Rafael here, he does this geospatial data management and stuff, let's assume.
Sure.
You go ahead.
Let's say you want to look through a code base, right? It's a very massive code base.
Yeah.
And you obviously have a RAG system set up and whatnot. And what you want to do is you just want to find the file that has a function that deals with a certain behavior. Right? I want to find the file that contains database code because you're doing a port or whatever. For that, and let's say you are building your own setup here instead of using an off-the-shelf thing. What you're going to want to do is you're going to want to set temperature to be somewhat low. So let's say your model likes 1. Your model provider says 1 is the ideal temperature. You want to lower that to maybe 0.7, 0.6. You're going to want to set top K to something very low, maybe 10 or 15.
Okay.
You're going to want to ignore top P because top P. If you're saying top K is kind of not really that unnecessary.
Okay.
Also min P. You want to do only like one of those three realistically.
I see. Of these three, it is enough if I set one of them. Okay.
Yeah. Top K tends to be the most performant, so you're gonna want to top K.
Preferably top K, and don't touch top P and min P.
Well, I'm not saying don't touch. It depends on the situation.
Okay. Yeah.
I personally only touch top K, but again, there's certain situations where you want to touch top P and min P, where if you're doing something like writing aids or whatever. If for this case I touch, I mean, for all the cases I'm gonna touch top K. You don't want to touch top K to like 5 or 10, like something very low. Because you want a little bit more deterministic. I want the correct answer.
Okay.
Then you're not going to be touching XTC or probability threshold because again, that's another one of those two.
Yeah.
You're always at max tokens here because this is like your limit. You don't want to set something crazy high, like 8,000.
So that is this the context window?
No, this is not the target. This is the number of output tokens. So you know how the models do next token prediction? They do token by token by token by token.
Yeah.
You go max tokens basically just stops it once it generates like 8,000 tokens.
Okay.
You can set context window limits in Llama CPP, but not here. And setting context window limits is actually very helpful.
Wait,
very
I'm
nice
not clear. So when output comes, so if I say maximum tokens of 8,000, then it will come from 8,000?
The model will generate up to 8,000 tokens.
Okay.
And then once it reaches 8,000, only. And once it reaches 8,000, it cuts off. You're done. You have to like
then
retry.
Better I don't keep any limit, right?
It depends. Remember.
Okay, give me a use case where I want to cut this model output token to 1,000.
So you set. Technically, you're not going to want to set max tokens here. You're going to want to set max thinking tokens.
Okay.
Which I don't know. That's not an option in this UI, but
sure. So we'll go to the command line next. Okay.
Yeah. You want to set max thinking tokens because then you let it think for a constant amount of time, and then you can have the output be like whatever the output is.
Oh, yeah. Limiting the time is very important. Yeah.
Yes. Because if it's in the thinking phase, nobody's going to open that up and read it. So it's effectively like dead time. Where the model is thinking, you have like a spinning bar. The user is doing nothing. They're waiting. It's like bad UX.
Yeah.
Right? So you set this maximum, and then now you have a deterministic amount of time until the model will respond.
Okay.
It can obviously like be faster, but but that's a good thing. The model is responding faster.
Yeah. Okay.
Samplers is just like the order which the things above are applied. Like, don't worry about this. You're not gonna be doing crazy stuff there.
Okay.
And backend sampling is just do this like the sampling on the backend instead of the front end, and then this means you kind of lose control of this from this UI, but you have to go to Llama CPP for that.
I see. Okay, let us continue our journey here. Just tell me wherever you want to stop. I'll stop, and then you explain whatever interests you.
Okay.
I'll just make it a bit bigger.
Yeah. You make it a lot bigger.
Yeah.
Cool. So the stuff at the top here is just like how like CPU stuff. You don't have to. It's like how many CPU threads or whatever.
CPU affinity orbital long X. Okay.
Yeah, this stuff like it's like if you're going crazy with the optimization if you're using it because you're doing both combo CPU GPU. It's
yeah.
Crazy.
Okay.
The first one I want to talk about here is dash C or dash context size.
Oh.
No, not that one. Dash lowercase c. It's a little bit.
Oh, here, yeah. Oh, okay. Yeah.
So what this is this is the maximum size of the context that the model can have.
Okay.
And so this is good for if you're trying to fit the model, like a decently big model on a certain GPU. So let's say you have a model and the model weighs, let's say 4 GB.
Yeah.
Your usage of the model will not just be 4 GB because you also have to store context on the GPU. And let's say you have 6 GB GPU.
Okay.
You don't have enough space for the full thing because normally if you're going full like 200K-ish tokens, that's an extra 4 GB on top. But
wait a second. Why is 200K 4 GB context?
It depends on the model exactly.
Wait a second. I'm okay. Till this minute, I always thought if you have like 200 KB, of text file or whatever, it only needs
Yes.
200 KB of memory. But you're telling
No.
it's 4 GB only for my context?
Because of the KV cache. So when you're running the model,
Yeah.
each attention layer has this thing called KV pairs, key value
Yeah.
pairs.
Okay.
Right? As you run your context through, it
Yeah.
stores it as a cache. So that
Mhm.
later it doesn't have to recompute that for every token generated. It
Mhm.
can like keep like 99.9% of the compute the same,
Mhm.
and then like just like run just with the new token added basically.
Mhm.
And that's your KV cache. You do not want to regenerate this every time, because if you regenerate this every time, you're doing like 200x the compute, which is like not good.
Wait a second. KV cache is within one request response or even for my next request response?
Even for your next request response.
Oh, wow.
Yes.
Wait a second. Then my token cost is going to be cheaper, right?
Yes. So this is why one of all these like model providers,
Yeah.
Deep in particular is famous for this. They
Yeah.
give you like a 90% discount if the stuff is in the cache already for input tokens.
Oh, okay. So higher the cache, it is cheaper for me and for them, right?
Yes. If you like are able to use the cache more and more effectively.
Okay, but Sanjay, what I thought was, even this is what I spoke to last week. So
Yes.
question, response, and in the
Yes.
next question, it goes question, response, question.
Yes, that's the input. Yes.
Correct. And then question, if there is like 5 times I've asked, then
Yes.
6th time if I ask, it sends the 5 questions and 5 answers and this one, right?
Yes.
But
yes.
fortunately, I'm not paying money for the whole thing because part of it is in the GPU's cache already. So they are not
Yes.
going to charge me fully.
Yeah, they're charging you 10%.
Only 10%.
Only 10%. Well, I think DeepSeek might be 5% now.
Thank
it's crazy.
you. Today I learned.
Well, okay. Note on that, OpenAI and Anthropic and whatnot are like somewhat funky with this. So you're gonna have to check their API.
I know, but even if they give us 10% discount instead of 90, I'm happy.
Yes.
Like
yes.
I was always worrying to minimize the number of QA, like, it keeps on going. Okay, so even if it keeps on adding, because of this concept of KV cache,
Yes.
the subsequent QA is only, they're going to charge me only 10%.
Yes.
Thank you.
Yes. But note, the KV cache is very expensive on memory.
That is their problem, not my problem.
Well, you're running Llama server, so now
oh,
it's your
in my server. Okay.
Yes.
Okay. So if my machine has, if I got only 8 GB vCPU, and if I have 100 users using this company,
Yes.
then I'm in serious trouble.
Yes. Which is why you said -C. So let me give you an example. Let's say you have a model that takes up 4 GB of VRAM, and then at 200K context, it takes up another 4 GB of VRAM, but you only have 6 GB of VRAM available. Right?
Mm.
So you have to cut your KV cache in half size.
Okay.
So you set -C instead of the default of 200K, you set to 140K,
Okay.
which cuts the size of the KV cache in half.
Okay.
Because it goes up the square of context. Right?
Yeah.
If you double the context, the KV cache goes up 4x.
Yeah.
Now it can actually fit.
Okay.
But okay, great. Now let's say you have like 100 users,
Yeah.
and then let's say you have a bigger GPU, because this is crazy restrictive. But let's say you have a bigger GPU.
Yeah.
What you can do is you're going to realize that you want to lower the number of people, like you want to like increase the amount of like concurrent KV caches that are like on memory.
Okay.
So you're going to like lower context size to something that like probabilistically works for your use case, right?
Mm-hmm.
So this context size, what you want here when you're setting it up is you want the maximum possible number that still fits in your GPU VRAM when you're using it.
Mm-hmm.
Yeah.
Hey, I have another question, because I want to have a clear mental model of how all these things work. Okay.
Yes.
So let me share my screen and we will go from here. See now,
Yes.
Sanjay, let us say this is our GPU. Okay. So now assume this one user one
Yes.
sending this request. Okay. Then
Yes.
request and response, request, response, and it is going like this, okay? And then he
Yes.
adds and all those things. Now, let us assume user 2 comes, okay?
Yes.
This is user 2.
Yes.
Now, let us say this user's one's request, we are flowing, and then
Yes.
this guy is coming, and then after some
Yes.
time, this guy is thinking, and then he fires his question, and it goes like this, right? So, and then obviously, my VRAM, like this guy, let us say, he is using, say, 0.1 GB of VRAM.
Oh, it's going to be more. It's going to be more.
VRAM. Okay.
Yes.
Okay, wait.
It's going to be like 2, 3.
0.2 GB.
Not 0.2. 2.
What
3.
are you talking? If I'm asking what color is this
Oh,
sky?
that's going to be a lot smaller. That's going to be a lot smaller. But if you're feeding it documents, if you're feeding it that in like an enterprise use case, it's going to be like 2, 3.
What
GB.
are you talking? If it is like 4 GB,
Yes.
no, come back to our machine. The whole box itself is, I'm sorry, you have to accept this fact, okay? This my whole box is 8 GB only.
Again, this depends on the size of the model. If the model is smaller, the KV cache will be smaller.
Wait. So now let us say my model is 4 GB, okay?
If your model is 4 GB at 200K tokens used, you will have 4 GB of KV.
Okay, so let us assume one user is asking a question, okay?
Yes.
So now this whole thing is 8 GB. The user asked this question, okay? Step 1.
Yes.
Forget about all these things for now.
Yes.
The user asked question, and then my GPU is full already.
The GPU is full.
Okay,
Yes.
now let us say this guy gets an answer, he thinks, and then he asks another question inside the document or whatever.
Yes.
And let us say he has got a page of, let us say 0.1 GB of questions.
That's not how this works. It goes with the square of the amount. So let's say the first question. Let's say the first question.
Wait.
The first question takes up 2. Let's say the first question takes up 2 GB.
Okay.
The second question, with the same thing, you've doubled the context basically.
Okay.
Let's
And
assume you
so
double the context. That means you 4x the memory use. It goes to 8 GB.
okay. So then I can't even ask a question then.
Well, it's going to do CPU swapping, which is bad. It's going to slow you down.
What? So with an 8 GB machine, I can only have one user.
Yeah, you can only have one user, realistically. Yeah.
But wait a second. Okay, this is where the switching nature of this GPU comes, right?
Alternatively,
Yeah.
you lower the context available to people.
Yeah.
So that now they can only use 2 GB each. And then because of this, you will be able to have 2 users simultaneously on the same GPU using the same KV cache.
Sure, Babu. Sanjay. See, my point is, let us even fine tune this, okay? But my point
Don't
is,
use fine tune. Use optimize. Don't use fine tune.
okay, optimize, okay?
Yes.
So let us say 100 users are using, right? So let us say 0.1 second, this guy fires and gets a response. And let us say it only took 0.1 seconds to get this answer. Let it take 100% of the GPU job memory, okay? Or even let us say 1 second, okay? 1 second I request and I got a response. And then this user is going to come, right?
Yes.
And then, so even if there is 100 users, and if I keep on context switching between 100 users, right? Still everybody can work.
The moment you do a context switch between users, you invalidate the KV cache because you have to dump it, basically.
Really?
Yes, because you don't have enough space in the GPU. So
what is this?
So let's say the first one takes 2 GB and the next one takes 2 GB, and you have 4 GB free space after the model waits.
Yeah.
You're fine. Right? You're fine. Both of those can exist in cache, you're fine. The moment the third user comes in and they take up 2 GB, the first user's one has to get evicted.
So, but then you said if Claude, ChatGPT, if I ask 8 questions, it is going to fit in and I'm good.
Their GPUs, they're doing multiple GPUs together. So their models are like 2 trillion parameters, and then they have 10 terabytes of VRAM available to them.
Really? Tens of terabytes of VRAMs?
Maybe not 10 terabytes, maybe 5s. But yeah.
Wait a second. Okay, now, that is why they can do it. But then if I'm working for a small company, wait a second. are a medium-sized enterprise here in Canada,
Yes.
they truly afford this $5,000 box of 128 GB.
Yes, yes. And so if you're running a model that's like, let's say 27 GB,
Okay.
right, like a 2017 model, 27 GB,
Yeah.
then a full 200K context window is roughly another 27 GB.
Okay.
Okay.
Wait a second.
And
Let me go to 128 GB of VRAM. And
Yes.
you said around 32 GB model.
It's a 32 GB model, yeah.
Okay. Now tell me.
Then your KV cache, assuming it's not a mixer that's this model, your
Ah.
KV cache, you can see me in that, will be 32 GB for full context, 200K.
Okay.
So this is the maximum that somebody can actually feasibly use. Because 200, you can go to 1 million, but 200K is the maximum somebody can feasibly use.
Okay.
And because 128 is 32 times 4, you
Yeah.
can fit 3 users with maxed out things. Maxed
Okay.
out chats. No,
Only
obviously,
3 users?
they're not going to max it out. No,
Okay.
they're not going to max it out. Probabilistically, they're probably going to get to like 50 or 100K. Because at that point, it's like, those are just very long chats at that point.
Okay.
And so, because 50 tokens, let's say it's 100K tokens, that uses a quarter of the memory. So you can fit 12 users on the same box at 100K tokens max. If you max them out of 50K tokens, it quadruples again. So now you can go to 48 users.
Okay.
At the same time. No, this is at the same time.
Yeah.
Yeah.
Wait, 100K tokens is how many A4 pages of text?
Oh, it's a lot.
It is large.
But if you have thinking tokens in there as well, you can go.
This is like 300 A4 pages for 100K. 300.
Yes.
This is awesome.
Great.
So,
okay, your memory usage drops to 8 GB per user.
yeah.
So if you have the memory, it's a quarter of the memory usage. Like if you have the context, it's a quarter of the memory usage.
Okay. So if I, out of 128, if I remove this 32, around 80. So I can have 10 users continuously pounding the server then.
Yeah.
Comfortably.
Yes.
And each one of them will think as though they're getting exclusive access to the server.
Yeah, basically.
Now tell me.
Compute at that point, because you're doing 10 users simultaneously, then you might hit some issues, but
okay,
it's like, yeah.
Okay, now tell me one more thing. Let us say I have 100 users in my company and everybody pounding the server, asking question, continuously working and all. Okay?
Yes. Yes.
Now, what will slow down here?
It depends. So, if you give them enough context that you set a limit to like not 100, but like they 10,
yeah,
then the first thing that will slow down is the KV cache evictions will cause you issues, right? So make sure you're whenever they ask the next question, they have to re-index everything into the KV cache, and that takes time.
Okay.
And order of magnitude is roughly 10x slower than generation. So 10x faster than generation. So if it takes you, like, let's say 1 minute to generate 1,000 tokens, it will take you about 6 seconds to load 1,000 tokens.
Okay.
So if they have like a 50K token chat, and it takes them 6 seconds, that's 5 minutes just waiting on all of that to load back into the KV cache.
Really?
Yes.
5 minutes?
Yeah. Yeah, assuming normal settings. You can optimize this down, but there's some other consequences of that.
Oh my God, this KV cache optimization based on the company's users and the number of users is, I think, is a big challenge.
It's a very big challenge.
Very important, as you said. Yeah.
Yes, it's very important. Yes.
Oh my God. And then obviously, then we have to daisy chain this 128 GB machine based on the load.
Yes.
And that is why the RAM prices has quadrupled this year.
Yes.
KV cache.
Yes.
Okay.
Like if I take over the thing, a graph I think people should be aware of when doing it. Let me just take over the screen share.
Sure, please.
A graph that people should be aware of.
Yeah.
Is so this is going to be time to first token TTFT.
Okay.
This is a common thing for like performance basically. And then on the x-axis is like user count or whatever.
Okay.
Right, like number of concurrent requests, whatever.
Uh-huh.
What you're going to see is it's going to be like decently linear. It's going to be like basically flat at the start.
Okay.
And at a certain point, you're going to hit the compute limit of your system. And it's
Oh,
going to go up linearly.
okay.
Then you're going to hit the limit of your KV cache.
Uh-huh.
And then it's just going to like spike up to like here,
Mhm.
like boom.
Uh-huh.
And then it's just going to like go up like crazy. You hit a
Oh my God. Okay.
right? So you should optimize this, but you should also optimize your compute levels to bring to ensure this constant time to first token is like exists for as long as possible. These are like the two biggest like compute walls, and so you'll see these in the graphs.
Mm-hmm.
Yeah.
Okay. And is there any way, any technology where I can queue the users?
I mean, these things already do that. They already queue the users. But the problem, again, the problem here is the exact same that you encounter with like basically any other cache. Whereas you have limited space. Like let's say you have 10 people asking questions.
Yeah, yeah.
Right? You're using like 8 of them right now. And what you finish one person's request. So now you can use the extra compute to reload the KV cache in. Because you need compute to do this as well. Right? Because you're effectively pre-computing the results of like the past conversations, basically.
Okay. Hey, Sanjay, one more questions I have is, see, let us say 9 to 5 in Mountain Standard Time, people are here working and asking question and overloading this, okay?
Yes.
Now, from 5 p.m. to 9 a.m., what do I do with this thing?
I mean, it's just excess compute for your company. So you can use it for like research use cases or whatnot. So you can use it to like, you can use, because this is compute that can be used for anything. Like this is, compute is fungible.
No.
So if you're,
should I throw some agents to do some R&D work, or like what sort of usage?
I mean, it depends on what your company is doing, right? You can have this run your own test cases, right? You can have, because you know how in theory you can have your own private evals for the models. Over the night, you can be like, hey, I want to run some private evals on like these different models, where I measure the like performance, I measure the like, I guess there's multiple performances, but I measure the like compute performance, I measure the.
It's not. Look, there's only 40 working hours in a week, okay?
Yes.
We have 24 into 7 number of working hours, which is like 66% more time. What do I do in the 66% usefully? Because I've done this investment of $100,000.
Yeah, I mean, there's really like, again, if you built this out as inference for your company specifically,
yeah,
and your company only works 9 to 5 in one office,
yeah,
there's really not much you can do. You can export like a bunch of your personal, like your dev use cases of it to this compute in after hours. You can do stuff like that. But other than that, it's like not really a crazy amount. Unless your company, again, needs the GPUs for something. Right? If your company's doing like fluid sims or whatever, it's like, great.
Sorry, what sims?
Fluid sims or...
Oh, fluid simulation. Oh, yeah.
Fluid sims or like
ML Geo. Oh, yeah, the oil and gas company, I'm sure they can make use of this.
Yeah.
Oh, yeah. Okay, gotcha. Thank you.
Yeah.
Now let us continue with our journey.
Yeah.
Anybody has got? Yeah.
Yeah. Anybody has questions? Put it in the chat. Underneath the -C setting, I remember seeing. Yeah.
Okay.
Yeah, I remember. Yeah, -N. -N dash predict. You should not be touching this in an enterprise use case. However, it's really fun to play around with. You get the models to just get a free 2x speed up, just like for free 2x speed up at the cost of performance. So it gets dumber, but it runs twice as fast. So it's really fun to play around with. But it's like it gets dumber, and like I guess it depends on your use case. But
okay.
Yeah. Then batch size. This is the number of requests that the server can process in parallel. This is something that like you basically, again, like normal, you figure out the space in your GPU and then you set it to be whatever is the maximum there. This is not super important to optimize. Just make sure it's like a somewhat high number. The default of 2048 is good enough for like basically everything. Like you just don't have to touch it really.
Mhm.
You don't have to care. So there's some optimizations you can make with that.
Okay.
Then do not touch dash keep n. So dash keep, don't touch this.
Okay. It's
yeah.
okay. Just tell us what has to be touched.
Flash attention. So dash FA.
Yeah.
You want to make sure flash attention is always on when possible.
Okay.
It's a free speed up. It's a free speed up that has like no consequences.
Okay.
I don't know why I guess auto being a default is fine, but like make sure it's on whenever possible.
Okay.
Great. Great. Rope scaling. So depending on the model, you can change this out. But so rope scaling basically what lets you do is, let's say you have a model and officially they only support 32K tokens max, like tokens maximum. With rope scaling, what you can do is you can be like, okay, your context window is actually 200K. You can just take a model with like a stated 32K and you say it's a 200K context window, go. And it like works really well. The problem is again the VRAM scaling. So Yarn is also good. So play on that. So if what you're doing is you take a model that's like 32K tokens maximum, you can like extend it, you can like decrease it, like you can play around. And so it lets you do that.
Okay.
KV offload. This is very important. So with this enabled by default, this lets you effectively keep the KV cache saved, but lets you offload it to main memory if it like gets ejected, and then it gets offloaded again at a later point. So this saves you a whole bunch of computation time and makes it so the spike at the KV wall is like smaller, but there's still gonna be a spike, but it like lowers the downsides basically.
Okay, but Sanjay, so main memory is comparatively cheaper.
Yes.
So then I'll also load it with 128 GB of main memory, no, in addition to my 128 GB on this thing, right?
Yes.
Oh.
Again, but you still hit a wall because you have to transfer that data from main memory to GPU memory, which is slow.
Which might be slow, but at least I have a choice.
You have a choice, yes. So this is a setting you should know about, and so you can like.
But default it is enabled,
by
right?
default it's enabled, but there's use cases where you want to turn it off. Because if you want to maintain a decently constant like performance amount, you keep it off. Again, it depends based on your use case and whatnot. So if you're running a very low main memory but high VRAM system, like if you like min-max the money aspect of this, you keep it off, and you have main memory just for like the host operating system, basically.
Okay, wait a second. Let me see this. See now, so this means it's using the GPU. This is CPU and the GPU like that, right?
Together, yes.
Now, why is my shell using the GPU?
To render.
To render? What is it rendering, sir? It's a shell.
Text.
Text rendering? CPU can do it awesomely, right?
You know how many pixels your screen has?
Okay.
You're rendering a graphical application. You're rendering a graphical application.
But seriously, but my GPU is expensive. I don't want this shell to use the GPU. CPU is okay.
Yeah, you tell your shell to use your CPU. Well, your CPU has a GPU in it for this use case. Integrated graphics.
Fine.
You have to tell it to do that.
I'm shocked. Why this Llama server is not using GPU?
It's compute. It's using compute. It is using a GPU.
Hey, it says C.
Type. There's two different types. It's compute or graphics. Sorry, C and G. Compute and graphics. So this is just compute. Just compute. No graphics.
Maybe it is running on the x86-64 itself.
Nope. That's running on GPU. It's doing compute on the GPU, not graphics. The GPU has multiple different types of cores. Compute cores, graphics cores. They can sometimes mix. So if you see C, it's doing compute on the GPU. If you see G, it's doing graphics on the GPU.
So GPU also can do like CPU?
No, it's a GPU compute.
Give me an example of a GPU. See, there is matrix multiplication.
That's compute. That is compute. That is C. If you're only doing matmos, you will only see a C.
Okay.
If you're rendering pictures, you will see a G.
Oh, so G is for graphics only, and the C is for compute, and this C is the GPU's C.
Yes, the GPU's compute.
Okay. And then where is the compute on the Intel?
That's not in NVIDIA SMI.
Oh, this NVIDIA SMI only shows about NVIDIA.
Yes.
Oh my God. Today I learned.
And then top only shows your CPU and it doesn't show NVIDIA.
Wait. Then what lie is this then?
Top shows, yeah, it's using CPU.
So
It's a web server. You start up a web server.
correct, which is
The
in
web server.
CPU.
Yes.
And this bin llama server, which is also here.
Yes.
Wait a second. The bin llama server.
It
Okay.
orchestrates the GPU.
So the CPU, the x86-64 started this, but
Yes.
it is actually being worked on inside the GPU.
Yeah. So the x86-64 will send your tokens to the GPU, and the GPU will compute on them.
But sir, this is a process, right? There is no compute.
Yes.
There is no nothing.
Yeah, but it's a process with multiple threads, one running on CPU, one running on GPU, basically.
Oh, even though it started in CPU, the CPU told, hey, take this Llama server, run in the GPU's compute.
Yes.
Oh my God. So this orchestration is happening already.
Yes. Well, technically, this is the CPU saying this. It's technically the same process, but it's basically just reserving memory and saying this is going to be compute memory for the GPU.
Okay, and then the CPU also said this shell, hey,
Yes.
you run inside the compute of the GPU.
You run inside the graphics.
The graphics part of the CPU.
The GPU, yes.
Graphics part of the GPU.
Yes.
And it also said this whatever PTY XIS, it said
Yes.
Like CPU would have started this, the x86-64. It would have
Yes.
told, hey, PTY XIS, you go and use both the compute of the
And
GPU and the
Yes.
graphic part of the GPU also.
Yes, you're doing both types of compute.
Oh my God. Like, how is this already solved problem, Sanjay? Like, people have solved this. It's awesome.
NVIDIA solved it. That's why they're a multi-trillion-dollar company. And Intel and AMD are not.
I'm sorry. Okay, thank you. Let
Yeah.
us continue the journey here. Okay.
Yeah. So that's just offloading stuff to the CPU.
Is there any use case where having 128 GB of main memory will be useful and utilized?
It depends. It's okay. The thing about just leaving it in like having like main memory and you use it is it's the fallback. You only use main memory if your GPU can't handle it. It's a fallback. If you're properly specing things out and whatnot, you really shouldn't be using this at all. But it's a fallback. It's a backup.
This is like using swap.
Yes, it's effectively swap.
Swap is 1,000 times slower than RAM.
Yes.
Right? And then, okay. 1 second, I have to restart this guy. Come on.
It is effectively just swap. It's are you enabling or disabling swap?
And you know how much I hate swap. I throw extra money for RAM all these decades, but not from this year.
Yeah.
Okay, let's continue the journey.
Then CTK is important. CTK and CTV is the data type. So you can store the KV cache at a lower precision to effectively save on memory, basically. So you can take it, like let's say your model, you're running in a Q4 quantization, you don't need to store your KV cache at F16 all the time. You might be able to get away with storing it at Q80.
Yeah.
And then you effectively cut your KV cache in half. So you can, in theory, allow your users to use 40% more context, or you can like have twice as many users before you hit the KV wall.
Awesome. So I can double the users if I correctly fine-tune this parameter, or if I don't correctly fine-tune this, half of the system will be wasted.
Yes.
In theory.
Yes.
Super. That's a big deal.
The default is good for like keeping it high quality.
Yeah.
But depending on, you can actually play around. You can increase it to F32 if you're running the models at a higher precision. to like do stuff. So like this is a thing you can play around with based on your use case and like user count and required accuracy and whatnot.
Okay.
Next, mlock and mmap. So if mlock, what it is like let's say you are loading a model into GPU memory and whatnot, right?
Yeah.
And it's also going to store a copy in CPU memory, just for like CPU offload and whatnot. This basically blocks it from swapping or compressing it or whatnot. It keeps it fully.
And
If it
this
needs to make
swapping is the disk swapping.
this is disk swapping.
Oh my God! Don't even talk. I don't. I can sell my blood not to swap.
No,
Sorry.
then you have to enable mlock.
I know. By default, I hope it is enabled.
I don't believe so. By default, it's not enabled.
But Sanjay, from GPU RAM to the memory, I mean,
Yes.
the CPU RAM itself 1,000 times slower. That itself you're discouraging. Now,
Yes.
who want to do something which is still 1,000 times slower?
People on memory constrained systems.
Poor people,
Yeah.
peasants.
Yeah, I mean, the defaults are meant for everybody, right? So if you have the defaults enabled, it shouldn't crash the software when you try to run something.
Okay.
If
Super.
you turn
Thank
on
you.
mlock, it could crash the software if you don't have enough memory.
Yeah, I don't want to swap at all. Please.
Yeah.
If somebody asks me to swap, I'll go back to my dad's textile business or I'll do farming. I
Yeah.
can't do swapping. Yeah.
Numa, you can scroll down at this point.
Sure.
Dash
where
list
to
devices
stop.
is good. Dash list devices is good for just like, hey, what can Llama CDP actually see and not? So if you're doing like debugging, you want to use dash list
Oh,
devices.
debugging is okay. Yeah.
Next, CMO and NCMO. Scroll up. Great. So these are basically how many layers of the mixture of experts model are you going to be keeping in the CPU versus the GPU.
Oh.
So because what the thing about mixture of experts is that they're computationally a lot cheaper, but they require a lot more memory. So what you can do in theory is you can set the mixture of experts model to have let's say it's 8 layers. You set the first 2 layers on CPU, remaining 6 layers on GPU, and in theory, if you like optimize these ratios well enough, you're not actually losing that much from the CPU GPU barrier.
Okay. So I can still run. Okay.
Yeah. So let's take an example of a model like Quen 35B A3B.
Yeah.
It's a model that needs 35 gigabytes of space on disk, assuming you're not doing quantization type stuff by default. But let's say your GPU is only like 32 GB, and you also need KV cache as well.
Yeah.
What you can do, and because you're only activating 3 billion parameters at a time, what you can do is you can be like, hey, I want the first like 10% of this model on CPU, and then 90% of maybe like 25% on CPU and 75% on GPU.
Okay.
So now you only need something like 25 GB of space on the GPU, and then you have like a small context window so you can fit it in the next remaining 7 GB. Okay? Great. So now you can fit a big model that performs slightly worse than a 27B model, but you can still run it faster because it's a mixture of experts model, and you're only activating 3B parameters at a time. So this is very useful for like fitting it onto systems that like models otherwise have no rights to fit in.
Okay. Wait a second. I have a question.
Yes.
NVIDIA SMI.
Yes.
Okay. I thought like, a GNOME shell without GPU will be uglier.
Yeah, that's on the GPU. That's on your GPU.
Correct. So it is beautiful. That's why it is beautiful.
Well, it's fast. If it's not on your GPU, it's going to be slow.
Oh.
Slow enough that you can't actually like use it.
I see. Okay, gotcha. Thank you. I mean,
the highest resolution you can get with CPU only is like Doom 1996.
Okay. So sorry to go back to the thing. If my LLM is using MOE, then it is smart to send a partial load onto my CPU.
It is smart to send a partial load to your CPU if you want to allow higher context sizes for your users, or you don't have enough VRAM in the first place.
Okay. See, I never thought that I need to even care about my CPU, but this is the first time I'm seeing more CPU is better.
You use CPU if your GPU is not good enough. The problem is basically nobody's GPU is good enough if you're doing this right, if you're trying to optimize for money. Because GPUs are exponential. Like,
Yeah,
if you want a twice as good GPU, it's going to cost you like 8 times as much.
I see.
Because NVIDIA
Really?
wants money. Yes.
When
You
is
know how
who are we getting released?
Huawei is not making consumer GPUs yet. They're entirely enterprise inference focused.
I know. Okay. Sorry, you're saying something?
Yes, great. So there you go. This is just like, if you want to like make sure things fit on your computer you have available, these options are very
One
useful.
more question. When it comes to the CPU,
Yes.
how do you compare x86-64 with ARM 64?
That doesn't matter. x86 versus ARM doesn't matter. The specific CPU architecture that matters.
Wait. But ARM is like 4x cheaper for the same
Yeah,
CPU power.
It's going to be 4x worse. For
Really?
these things. Yeah, x86 is very good at like doing stuff in parallel.
I don't think so, but I'll agree with you for now.
Like if you
Hey, at least I'll save in power, no?
Yeah, you'll save in power, sure.
But wait a second.
Well, no, not necessarily. Not necessarily. If you're doing this right, the most recent Intel CPUs are the most power efficient CPUs on the market.
But wait a second. Then Apple. Then all Apple are ARM only.
Yeah, ARM versus x86 doesn't matter. It's the CPU designers things that matter. Because they're compiling it anyways. The compute is not happening on ARM or x86. It's happening in micro-ops that the CPU is executing.
Mm-hmm.
There is a compiler on the front end of the CPU that compiles your binary.
Okay.
So, like, yeah, the compiler might be like 1 or 2% worse on like x86, but that doesn't matter. Most of the compute is happening in bytecode anyways.
Mm-hmm.
And if you're already having a compiler on the front end and running stuff in bytecode on the back end,
Yeah.
it's like ARM x86, it doesn't matter. The thing that matters is the licensing cost for like buying access to the license.
I see. Okay. Let's continue the journey.
Yes. NGL is basically the same thing, but how many layers go on a GPU?
Okay.
Yeah, same type of concept. MG, main GPU index.
Yeah.
How long a CPP works and basically all of these things work is there's a main GPU that handles most of the work, and then if you have like other GPUs, you can like work with it. Now, obviously, if you have multiple GPUs, you should probably be using VLLM. But if you have multiple GPUs and using Llama CPP, you have a main GPU set, the main one to be your biggest GPU, basically. So this can like you can change it.
Mm-hmm.
Basically, you pick the one that's either physically closest to the CPU on your motherboard or whatever, right?
Sanjay, as we are speaking about multiple GPUs, right? See,
Yes.
now when I went today to buy this, I mean, there is one guy in his home, 10 minutes drive from my home. His home is filled with servers and GPUs, and then laptops and hard disks and everything. Okay, in his PGG, he has listed like 500 stuff. Okay, I did not even go through all of them. Now that guy, I was negotiating with him. Okay, so this deal is very simple. NVIDIA SMI. He said, "Hey, look, this particular model is a newer model of the GPU. For $120, I'll give you 8 GB VRAM. But the same $120, I'll give you 2 GPU, each 8 GB, but it is 4-year older. Like this is 8-year-old, that is like 12-year older.
Yeah, but you get 16 GB total VRAM.
Which is good, right?
It depends, because there's bumps here, very big bumps. If it's something older than the Ada Lovelace architecture, I believe it's called, the RTX 2000 series, basically.
Yeah.
It becomes a whole lot worse.
But then I got 16 GB. I can load more, even if it is slower.
You can load more, but it's going to be over 4x slower, 6x slower, 8x slower. It's like crazy.
4x slower. Okay.
With the RTX 2000 series, they made a whole lot of improvements. Then for Hopper, with the RTX 3000 series, they made even more improvements.
I see.
Right, and then obviously the newer ones are even more.
Okay, so this is not a bad decision then.
It's not a bad decision, but again, it depends on the use case and models and whatnot.
Yeah. So that guy has got so many servers and so many GPUs. It's all like $100 or even $60.
If it's $120 each, you buy both and you use them for testing and learning.
Yeah. He sold me this for $120, and he said the older models, like I'll give you like double. I mean, at the same price. Yeah, but anyway, but I'm going to. I'm going to bring another 8 GB and then maybe slide it inside this box only.
Sure.
Another $120.
Yeah. Okay.
Thank you.
Great.
Okay.
Scroll down here. Dash LoRa. So if you're using LoRa's for your models, this is where you set it up.
Okay. What is a LoRa? Quick intro, please.
So LoRa is a way to fine-tune models so that you only change like a certain percentage of the weights at a time, and it's like faster, more efficient. It's like
we are not fine-tuning, no.
Yes, but if you are fine-tuning, this is what you're.
This is what it is. If I'm fine-tuning.
Yeah, it's just good to know about.
Okay, you know what? Let us spend a couple of minutes to explain to the broader audience here what is fine-tuning and how tough is it or how easy it is, like fine-tuning an existing LLM.
Okay, yeah, I mean, it's fine-tuning an existing LLM is very much like you have your base LLM and you're like, I want to make it better at this specific use case and I don't care about anything else.
Yeah.
So you have a bunch of examples that you give to the LLM of like, here's the input, here's the expected output, and you effectively just feed it through the LLM and you train it on all that data, and then you will have a fine-tuned model at the end of it that is trained on your data that is going to be slightly better at your use case. It's just a lot of work, like making sure you have a clean data set, making sure you set your parameters right. Like there's software that can help, right? Like I used to work at this company called Transformer Lab. They make very good software for this type of thing. But again, it's like if you're a company, unless you're doing something that like you want to hyper optimize for that the model companies aren't optimizing for already, it's like you don't need to worry about it. You don't need to
Sanjay, if my aim is to have a job in the next 5-10 years, and you are saying this is lots of work, I'm happy. So I want to learn skills here. If I go to a large company,
it's lots of work for very little business value. If you're trying to maximize the amount of business value you provide to your customer, basically, you're not going to care about this. You're going to focus on setting up these other settings, and your effort is more valuable in optimizing other settings here.
But after 3 months, if everything is ready and then I don't have much work, then maybe I'll focus on this. No.
Maybe you can try some stuff there. Yeah.
Thank you. I mean, I'm very happy. If you say there's lots of work in this area, lots of optimization, I'm happy to hear. Sure. I want to learn. Thank you.
But you just ignore it for now.
Okay.
You can come back to it in 6 months.
Thank you.
There's some settings here for just which model to use. So -M lets you connect it to a model that's on your disk. -MU makes you connect it to a model that's in the Hugging Face.
Directly I can pull a Hugging Face model.
Yes. -DR connects you to a Docker repo with Llama CPP stuff, so you can do stuff there. -HF goes specifically to Hugging Face. -HFF it's just a bunch of settings.
Wait a second. Yes. So if I say .dr and I can, this will download a LLM from Docker, and I mean, it'll go there, search, and then download, and locally it will run.
It'll run that Docker container locally.
And this GPU is inside the Docker container?
Yeah, it'll feed through the GPU to the Docker container.
Oh, look, I was not sure that I can tell a Docker container to take over my GPU.
Yeah, you can. You can. It's just a massive pain, and
So this is not recommended then?
It's not recommended, but it's nice for Kubernetes. If you're setting up Kubernetes, this is, I believe, how Kubernetes plugs into a decent amount of stuff. At least some of the stuff I've seen online.
Wait a second. But then the problem is this optimized? Directly it can go?
Yeah, it goes directly, but there's a small layer in the middle. It's not that optimized. It's fine.
5% loss?
Yeah, 5-10%.
Super. Okay.
Yeah. A whole bunch more settings here for pulling stuff. Logging. There's some logging stuff here.
No problem. This for logging.
That's for logging.
Offline.
By default, it doesn't go to the internet But like if you set up offline, it's like, hey, it's blocked you from even going to the internet wherever.
Which is good. Yeah.
For like even for like downloading models, it'll like block that as well.
Yeah. Okay.
Log. Spec draft K and spec draft V. This is speculative decode.
Uh-huh.
So if you have like multiple models doing stuff, so that's, I don't know why that's in that section instead of a lower section, but that's like if you're doing speculative decode, that's what those are. Temp top K, we covered this already.
Yeah. Repeat penalty.
Yes, repeat penalty is basically like if the model outputs the same token multiple times, there's like a penalty that like to that token basically.
Sorry, what? Why there's a penalty?
So previously, models had a failure case where they just output the same token continuously until they hit their output limit. So if you set up repeat penalty to have a high enough penalty, it will stop that failure case basically.
Mm-hmm.
But the problem is sometimes this like screws up some like arithmetic reasoning and whatnot. So you want the repeat penalty, but you don't want it so high that it like kills arithmetic capability.
Mm-hmm. Okay.
And a bunch of these things basically just stop that failure mode because that was like going kind of crazy for a year and a half basically.
Mm-hmm.
Yeah, even more. Scroll down. Most of these are the same like failure mode stuff. Backend sampling. This is for if you want to enable backend sampling here. You enable it here, and then it. Yeah, this is where speculative decode stuff comes in.
Okay.
Yeah, it's like
what speculative decoding?
Speculative decoding is if you have a model, let's say it's a 30 GB model.
Yeah.
You have a small 3 GB model.
Yeah.
That generates, and you get that small 3 GB model to generate 10 of your tokens. Then you have the big model. You run it once on all 10 of those tokens simultaneously to effectively verify that yes, this is good.
I am not understanding, but looks like an interesting concept. So what you're saying is, okay, so now you're saying I have a large model. Okay, I have 128 GB, okay. So I have a 32 GB model, and also I run a 2 GB model at the same time.
Yeah,
Sorry?
3 GB model.
Okay.
It doesn't matter. You can make 2 GB, it's whatever.
A small one, okay.
Model. Yeah.
So now what you're telling is a user request initially goes to this model, and this guy gives 10 tokens, is what you're saying.
Normally it's like 3. Normally it's like 3, but yeah.
Just 3 tokens output.
Yes.
And then what happens? These 3 tokens are sent to this guy.
Yes, and it verifies all 3
parallelly.
In parallel. So what you're effectively doing is to generate these 3 tokens, you're paying the cost of generating 3 tokens with the small model, plus the cost of generating 1 token with the big model.
Okay.
So if your small model is small enough, you can effectively make it so that this is cheaper. It's less compute. The problem becomes if it fails to verify, you effectively have the equivalent of a cache miss, where you have to run the big model for all 3 of those tokens before you try again.
So in what scenarios I will use this?
It's a performance boost. It's like almost free.
What is free?
This speculative decode. It's a very new technique. It's a very new technique, maybe like a month old. For like
just a month old?
Yeah.
And it has got some future?
Oh yeah, 100%.
Oh, so then better we learn this. So then, okay, then it is better we implement it, is what you're saying.
It's implemented in Llama CPP, but yeah, use it. Use the implementation in Llama CPP.
So then I have to choose 2 models, no? One small model and one large model.
Well, what they frequently do is they release MTP versions of the big model. That's like 3 GB. So you release, so like, I know for Quen 3.6 27B, they released an MTP model. So you use their MTP model and their normal Quen model. And yeah.
Okay. So if I decide to use this Quen model, then I also download a smaller MPP version of this Quen model, and then when I orchestrate these 2 things, I get benefits.
You get benefits, yeah. You get like normally like a 1.5 to 2x speed up. It's like pretty good.
Awesome. Thank you.
Yeah. So like almost free.
See, this is the power, right? This is where we, the masters, like somebody and like some learner is not going to know this, right? Now this is going to be my default architecture now.
Well, I mean, pretty big on Twitter for like 2 weeks. Like it was going crazy on there. But yeah.
And it is so fresh.
Yeah.
I am happy. Okay.
Yeah, so you have a ton of settings for a spec draft model. So yeah, the small model is called a drafting model. So that's why it's spec draft. It's speculative decoding drafting model. So you can set the params for that.
Wait a second. So this speculative parameters is what I set up on this guy.
On the small model, yes.
Oh, so there's lots of work for us, Sanjay.
Yeah.
Okay, give me 1 second. Oh.
Yep.
Okay, I'm back. So lots of work is coming, Sanjay.
Yes.
Good. There's lots of things to learn and to prove.
And one thing I will note is speculative decoding is one place where right now fine-tuning actually makes sense. Because what you do is you take one of these speculative decoding models and you look through the use case of your company.
Yeah.
And you fine-tune the speculative decoding model on the specific usage patterns of your company's use cases. So you can get a more accurate speculative decode model.
Yeah.
So that you can increase the number of tokens that this generates before getting verified and while maintaining probability of being verified.
Awesome. Wait a second. Let us make that.
This is one place where fine-tuning might be valuable.
For the first time, I'm hearing you in many years. Do fine-tune.
This is very new.
Okay. Wait a second. So what you're telling is, if at all there's a place worthy of fine-tuning, the best bang for your buck, it is fine-tuning is good.
Yes, for the draft model, yes.
And it is called
because if you're able,
model.
It's called a draft model. The small model is called a draft model. Because if you're able to, let's say, have the error rate of your draft model when predicting your the tokens, you can double the number of tokens it predicts simultaneously, which is basically like a doubling of speed, basically. Because the speed of your drafting here is almost entirely a function of your error rate. Because the small model is just simply so small.
Okay.
So yeah.
Wow. Super. Fantastic.
But again, this is purely a speed thing. It's not going to improve capability of the model. This is purely to make it faster, which is useful. Don't get me wrong.
I know, right? Obviously, because then I can load 12 users in the place of 6. No.
No, you will be able to load less users. It is each user will have the responses done twice as fast.
Okay. So the users are going to be happy at least.
Yeah. Instead of loading 6 users, you'll be able to load 5 users, but you can process the request twice as fast.
Twice as fast?
Yeah, twice as fast with default spec decode.
I'm sold.
Maybe you can go even faster with fine-tunes
and 3 GB is not even big, right?
Yeah,
if I have 128.
Yeah.
Hey, I have another question. Can I have multiple of the small guys? Okay, wait. Let me remove all these unnecessary things.
Okay.
Sorry, I'm thinking a lot. How does this make sense to you?
Why have 3 of them?
Because I'm a poor chap and I want to make things faster.
That's not going to make things faster.
Is it? Like this? Oh,
wait.
Wait. Like this.
Well, why are you not just using the same base model as well? Because those
Same
3 tokens.
Base model?
Yeah, those 3 tokens need the previous one. You're wasting 3 GB of memory here.
No. Let's assume the first 10 users, I'll send them here. The next 10 users, I'll send them here.
You just use the same base model. You point to the same point of memory. Yeah.
Okay.
There's no point. Yeah.
But I'm parallelizing the small guy.
You're already parallelizing. It's on a GPU. You're already using like 90% of your GPU.
You win. Okay.
Yeah.
Okay. So these are all speculative parameters which are similar, and I'm happy to learn and master.
Yeah.
This is needed only if I'm using this small kid in addition to the elderly.
Yes. These are random specific ones. These are just
KVU.
like, yeah, it's like, do you share it? You can ignore it. Most of these ones are just like, if you need it, it'll be there. You don't have to actually care. You can keep scrolling.
What is even a reverse prompt?
It's interactive mode stuff for if you're in interactive mode.
Okay.
Yeah.
Parallel, number of server slots.
You don't care. Like,
Okay.
again, these are like, you're running into an issue. These are like specific fixes for people's issues
Oh, okay.
that they've implemented.
So,
Oh yeah, there's some server stuff here. So host, port. So you can, if you're running Llama CDP, you can change the port. You can change the IP address.
That is sysadmin stuff.
Yeah.
Hey,
You
built-in
can-
tools for agents. Yes, I want this.
Okay. Yeah.
Don't I?
Sure. These are simple tools though. It's like edit file, read file, get date time. It's like if you're in a company, it's like 5 minutes to set these up. Like these are like fine, cool, built
But
in.
this is awesome power, Sanjay. Integrating tools.
If you're a company, you want to plug this into your own system, so you have to have your own tools anyways.
In addition to these default things.
In addition to the default stuff, yeah.
Okay. Agent.
Yeah. This is, again, that's just more tool stuff. Re-rank is useful. So if you're setting up a RAG database, you can set up the Llama CPP to do re-rank with the same model that you're serving with. Because each LLM has an embedding model that comes with it as like a first layer of the model. So you can actually rip that layer out and use it as the embedding model for your RAG database. So this lets you do that.
Sorry, please elaborate.
So how a RAG database works
Yeah.
is you have to embed the text.
Yeah.
And there's specific embedding models for that. But when you train an LLM, the first layer of the LLM is an embedding model that trains with the rest of the LLM.
Okay.
So with re-rank here, what you can do is you take the LLM that you've like given the Llama CPP to run. You effectively say, okay, only run the first layer. That's an embedding model now. Let's open up that endpoint on the server so that when we're running RAG, we can point it at the same model that we're doing stuff in. This is like not that useful, all things considered, but it can be useful in certain use cases.
I see.
It's a good thing to point out.
Mm-hmm.
There's SSL, API key stuff. There's sysadmin stuff. There's metrics. I believe the metrics here is for Prometheus. So you can get it connected. You have model dirs, so you can give it access to a full folder with a bunch of different models, and then the request we can like pick the model. So you can have your chat UI like have like 10 different model options by just having the models in a folder. And so model max there is for if you have like 10 different models available. This is how many models you can load at the same time. Again,
hey, wait a second. So one Llama CPP can run 10 models or 10 small models at the same time?
Yes, 10 different small models at the same time. Yes.
And then users can come and choose it here, right? Like I saw here, then the users can choose here.
Yes.
So this is the power to the user.
Yeah.
Okay.
Or a developer who's building your RAG application or whatever. You have reasoning budget, which is very useful. This is for not format, budget. You don't touch format.
Okay.
Reasoning budget, what this does is it's like, hey, you can only think for 2,000 tokens. It basically sets a time limit. It's like we were talking earlier. It sets a time limit on like until the response. Chat template is if you want a specific one, but like you really don't care that much. Because again, it comes with a GGov file. You don't have to care. They'll just read the GGov file and it'll be proper for your model. So you can keep scrolling. Yeah. Prefill assistant. This is for KV cache optimization. So if you want to like slightly optimize the KV cache to be smaller, you can set this to be off. And the KV cache will be smaller, but you'll spend a little bit more compute, so it like helps like smooth out that spike wall. It doesn't make it any better or worse, but you know it's there. If you go down here, there's just a bunch of models you can download. It just gives you a bunch of options. If you like use them, it'll like use the default.
But wait
like,
a second.
Yes.
Why is Llama CPP precisely speaking about Quen?
There's Quem, there's Gemma, there's GPT-OSS, there's Gemma. It's just a bunch of default models. It's just a bunch of default models. Yeah.
What default models? Anyway, I have to download it, right?
Yeah. Anyway, yeah, download it. Yeah, but like it'll download for you. It'll handle it for you. So if you just download Llama CPP and run it, you can just say, I want to run Quen7b. Go. I don't care.
Okay, it can download from internet.
And so, yeah, you can actually see some speculative decoding. It has some default speculative decoding ones. So for the Quen7b spec, it runs Quen 2.5 coder 7b with a 0.5b draft model for speculative decoding.
Oh, wow.
With a bunch of default settings there. Same for 14b. It runs the same draft model. That one.
Wow. So if I use this, then my users are going to get the response double fast, like faster?
Basically 2x, yeah.
Wow.
Yeah.
At the cost of 0.5b instead of like.
Yes.
Okay,
yeah.
Good to know. All good. Thank you. Anybody has got any other questions for Sanjay now before he goes? Okay. If not, thank you very much, Sanjay, for coming. And stay for some more time because we are just, I just want to ensure people have got access. And hey, Sippy, if you want, you can continue for a few minutes and just show us the shell and all those things if you want.
Okay.
Thank you. I'll stop sharing. Another 10 minutes, Sanjay. Sippy will show us this command line, and maybe he will stop from the command line and start it and see.
Also, you should probably unpin me from the main stage.
Thank you. Done. The demo guards are not helping. Okay, you are in. Okay, so now can you also show the browser in the other window? This is working for a minute. Okay, so yeah, now kill that Llama server process from the command line, just to prove that. Just make it to stop working. Kill -9. Go to the shell. Kill -9 77830. Yeah. Just type ps-aux pipe grep llama. ps space -aux pipe grep llama.
Grep.
Pipe. You have to put the pipe command. Okay, now the pipe is below the backspace in the top right of the keyboard. Okay, remove pipe. Yeah, just enter. ps-aux is good. Enter. Go to the top. Find out the PID of Llama server. Oh my god, so much process running. Okay. You know what? Press stop quickly for me. Press TOP, enter. Press enter. Don't even come down. No, TOP, not stop. Just TOP, enter. And press C in your, press C. Yeah.
See, yeah.
Now press M for memory. Do you see? Why don't you see the Llama server anywhere? Oh yeah. You see the Llama server somewhere in the middle, and 830 is the PID, right? So what you should do is kill Control C, or press C or Control C. Kill space 77830. Kill KILL space 77830.
Enter.
Yeah, it is killed. Now, yeah, now go back to the browser. It will stop working now. Type
Well, you're gonna have to refresh first.
whatever. Yeah.
Yeah.
Okay, now go back to the command line. You kill the process. Now is CD, like in this chat window, I put CD space LLAMA tab. Yeah, CD that, paste. Enter. Type ls, and then copy paste the next command. And this is where the trick is. Yeah. No. Yeah. Paste it. No, ls enter, or remove the ls. Control C. Paste. No ls needed. Yeah. Now right click and paste. Paste the other command. Okay. Now here, the context window, use your left arrow key, change the 60,000 to 10,000. Yeah. And change the NGL to 15. For fun, let us see if it runs. Yeah. Enter. Okay. Super. Yeah, it is failing because we don't have memory. So up arrow key again, and 15, change it to 12. Enter. No, not 112. Yeah, enter. Okay, this guy survived. Now go open the browser, refresh it. So you have started this Llama CPP server.
Okay.
Yeah, now you can continue to ask questions. So the thing is, we are reconfigured the Llama server with 2 parameters. There are 100 parameters to fine tune this. And you have changed 2 of them and rerun it. Okay, that's it for today. Anybody has got any other question before we log off?
Jake, can we see if I will be able to connect web server? If you have
Sure, 100%. Let me go to Tailscale, and in Tailscale, I'm seeing Himabindu. Okay, you cannot do this yet. So what I can do is, I'm going to remove CP from here, okay? I am going to delete CP, and I'll give you access to Hima. And CP, I'll give you access to the other server with 8 GB of RAM is there, no? Tomorrow. Okay, Himabindu, you should be able to connect now. The same commands.
1 minute, I'm just trying to log in.
Yeah, from a browser also you should try. You want to share us your screen, please?
Yeah.
Thank you, Hima.
I'm trying to log in.
Sure. Sorry, Nathan, you're saying something?
Yeah, for others, you will be able to do it tomorrow, right?
Correct. 8 other users I'm going to add.
Fine. So
because I just set up this machine today only. Okay. And hey, you know what? Wait a second. I should be able to give you access. Give me your email ID. I'm going to add you immediately.
Very good. Very good. Okay. It is G phone.
1 second. Invite external. Yeah. G.
You want me to? Okay. G as a
Yeah.
Google.
Yeah.
Phone. PHONE.
Yeah.
Then number 4.
Yeah.
And then Nathan NATHAN
Yeah.
at gmail.com.
Okay. Now invite external users. Come on. Okay, invite via email.
You are sending me an email now.
I'm trying. Copy, select role, member, copy invite link. Invite link created and copy to clipboard. Wait, that. 1 second. Wait, via email. It's not exactly working. I don't know why.
Yeah, you have some. You shared some Google account data with Tailscale.
You got an email now, right now?
Mail quit unexpectedly. Promotions 3. Apple didn't know. Not this one. Primary Google account with this. Yes, July 10th. No, it's old.
Okay, no problem. Okay, sorry. Tell me your email address again. I lost it.
Okay, it is G
Yeah,
PHONE
yeah.
4 number 4
Number 4, 2 and Nathan, right?
Nathan at gmail.com.
Okay. Now, use gphone42 Nathan at Gmail, right? So I sent you an email. You
Okay.
should get it in a second. Okay, Hima, could you connect?
Yes. Can I share my screen?
Please, please. Both from the browser and the shell, you should be able to connect. At least show us the browser.
Yeah. Are you able to see my screen?
Yeah, this we are able to see. But then you should go to the server URL. Where is the server's URL? CP, can you use the server URL here? CP, can you copy paste the server URL?
Yeah, I did it.
Thank you. Can you use this URL to log in? Yeah, try that one. I don't even know how it is going to work.
This one?
Yeah, try that. No, the account is never downloaded. No, go back. Try this URL which CP has copy pasted here. Yeah, the top one. Yeah. No, the top. Yeah, this URL. Yeah, click and let us see if it opens for you.
You want me to copy it and separate?
Yeah, in the next tab. Yeah. Yeah. Maybe your tail scale is not up. Is your tail scale client up and running? Download tail scale. No, at the bottom.
No, I have already downloaded, but
yeah, maybe you should start it up or something like that. Okay, like this. Maybe. Wait. No. Open it. Open it and ensure that it is connecting. And CP, you have to open the Tailscale software, is it?
I think we will have to open the Tailscale application. And what I did was I logged out from my account and I re-logged it again so that it went smoothly for me.
Okay.
No, it is giving me like this CB prepare and install. Even if I
No, don't uninstall. Do not uninstall. So this client you have to open up and then you should connect.
yeah, but I downloaded it once again today just to click on repair.
Okay,
Right.
go to tailscale.com and see from the browser you can do something.
This is the Tailscale browser.
Login. Okay. No, same page. Login.tailscale.com.
This one, right?
Yeah. That one only, yeah. And you log in from there. Yeah, click that. Switch tailnet. What does it even mean? Yeah, try that. Okay, here, wait. Desktop is connected, which is good. Go to the top somewhere. You can see this thing. Hima Bindu is a member. View edit roles.
Can you open your system tray, please? In the bottom taskbar, can you see an icon next to the Dropbox?
Oh, here you're trying to say?
Yeah, next left to that one. Can you see the arrow? So there's a Tailscale icon, the third one.
Yeah.
Yeah, can you right click on it? So can you log out it and can you log back in again? Yeah, log out. And then can you try logging it back in? So sign in.
hv.quest. No, it is hima84 at gmail.com.
Wait, can you choose jairam.linux email ID in this? Yeah. So now you can you reload the Llama CPP website?
Oh, the URL.
Yes. Yeah, URL.
J-HP. The fourth tab in your browser. Fourth tab in your browser.
Yes. Can you reload it?
One cognizant. Okay, this. Ta-da! Select both, or it's okay. Not now. Either case, fine. Not now is also good. Yeah. Super. Ask your question. So you are connected to the server which is running in the room here now. And similarly, you should go to SSH.
But it says
Shell.
one cognizant, not cognizant. Why?
That I don't know. But this is our server, as you know.
This is my.
No, you can copy paste the URL again if you want. Copy paste the digest.hp.tail that URL. Just click on that URL.
Not doing this.
Yeah, it's there. Just click it and it'll open. Yeah, this should. Super.
Okay.
Okay. Similarly, SSH also take close this one unnecessary. Okay, now you can practice this machine, but tomorrow I'm going to set up the more powerful machine so that it will be going to be faster and better.
Okay, so I can ask any question.
Obviously.
I'm just trying to say.
Don't copy our ideas, please. Come up with your own idea. Oh, models of? No. Okay. Okay. Well, see, in which country, which time, it's going to be complicated.
Okay. So
models of car at least is forgivable.
So, car and all,
Okay, go
fine,
ahead.
I'll say.
No. Trust me. Sorry, I should not have distracted you. Go ahead with your original question. Models of laptops or whatever you asked. Sure. Okay, let us see.
I'll just give
In India.
some
That
funny
is good.
figures.
You are very constraining the answer, which is good. Yeah. Whatever answer it gives, I'll be surprised. Wow, 20. Okay. Apple, Lenovo, Dell, HP, and Acer covering gaming workstation everyday use. Okay, your Chat GPT version 0.1 is ready for you now.
So I can
Our
ask
own.
a number of questions for you.
Yeah.
Right?
Burn the CPU. Ask 1,000 questions. But this is not as awesome as Claude or ChatGPT. You know that, right? This is a starting point. So don't trust this thing. Military grade certification.
Can I ask you a question, Jay?
Please, Nathan. Yeah.
See, once we are connected to this server,
Yeah.
and it is all the 24 hours it is connected, or how is it?
Yes, it is connected 24 by
Which
7.
means any query I make, it will only
Yeah.
go to this server, not to open ChatGPT.
Yes, it will only come to the box which is sitting here next to me in this table.
Okay, so in case if I want to get more information or faster or updated values and things like that, how do I change it? Like I have to disconnect this connection and go to normal open ChatGPT?
Sorry, the question is unclear.
Okay, question is, suppose I'm connected to your server all the time.
Yeah.
But I want to go to open ChatGPT for something else.
Open another browser, go chatgpt.com, whatever, and then you can ask there. They're very separate.
It will not go through your server.
No, not at all. Only
I
if you
see.
come to this URL, it will go to our server. You go to Claude.ai, ChatGPT, Gemini, and all in the internet, that will go there.
Okay.
And they are unrelated.
Fine.
Thank you.
Good. So I didn't get the email yet. I think something maybe not okay.
Sure, we'll see tomorrow then.
Can you check my email ID? I already sent it here. This is what you sent it?
G-phone. Oh, you got only one number 4. But
yes.
I remember 2 digits.
Oh, that's where it is. I didn't get it yet.
No. So there's only one digit number 4, is it?
Yes.
Okay, then let me resend that to you again. Yes, it was not delivered. Okay, try again now.
Okay.
Okay, that's it. Feel free to log off. Sorry?
I just wanted to know the password for the SSH, this thing I did, but I was not, but here I got it, the password.
Yeah, CP put the password, try that.
Yes, I got it.
Super. And then there is an URL. You should try to log into that URL.
Is somebody from India, Jaina, who is connected to that Olama? Because I think I'm only connected to this.
Please be a bit louder. I'm not hearing.
Am I audible now?
Yeah, better. See, from the browser, you could connect, na?
Yeah.
Similarly, from SSH also, you should be able to connect if you put this URL. So what's the question?
Yeah, I just wanted to check that. I'll try it out and get back to you.
Yeah. All 6 of you should be able to connect.
Okay.
At the same time. Okay. Thank you. Meet you all tomorrow.
Will you be sending the new server details in the email?
Sure. Yeah, I will be sending. The
Thank
new server. Wait a second. This you have this Uma Shatapuram already I sent, no? And it says connected also.
No, the new server. The
New
detail.
server, not for you. We have 15 people. The first server, first 6 people, and the other 6 people I want to give the new server. Because I only have 6 licenses no per server.
Yeah. Okay.
So
Makes sense.
sorry, you have to live with the smaller server only.
Makes sense.
Right?
Is
Yeah.
there like a minimum RAM hard
For
disk for trying out on our own systems?
any GPU, like you should have a GPU. There's a bare minimal requirement.
Oh, what if we don't have that? Then we can't.
No, it's not worth it.
What's
This is
like the average cost of this GPU that you're saying? Like if we have to buy it, what kind of
where
cost?
are you based out of?
Denver.
Madam, for 300. Okay. Did it not show you this awesome server grade thing with 64 GB of RAM and 8 GB, all for like $300 I bought? Like 300 USD you can go and buy.
Oh, in a local shop.
Oh, used one. Sorry. A used server. and used to. Okay, you know what? Let me show you how I purchased. Okay. $300 US, you'll get a very powerful GPU server or laptop. Okay. Let me show you. Do you see the screen here? Okay. This is what I did. This week and last week, if you spend like 200 to 300 USD, you will get a very powerful used server for this learning. Okay, now let me go and say NVIDIA in computer accessories. And this is how you should go and buy. I mean, brand new is about $1,000. Okay. See, now you can't believe. Let me look at. I think this is what I bought today. Okay. This GPU costs $75 if you have a desktop computer. You can, if you already have a desktop computer at home, buy this $75 GPU and then plug it in. Option 1. Okay. See, there are so many people selling lots of this GPU, and this is what, like 4 GB is $100, and you can find like somebody even selling for $10, right? Like $20 or so. 4 GB. This is a good deal. You saw this? A 4 GB video card, only $20, right? $25 if you put, you get 3 GB. So this GPU is what you need to run anything. Option 1. So do you have a desktop at home?
No.
Okay, then laptop means, okay, then
This is a very, very old laptop. I couldn't even, I have
how much
this.
is your budget?
No,
You
I
have to
thought
spend
this
for
is
this
this is
learning.
like a plug and play. Is this GBU's kind of plug and play or no?
This is plug and play for a workstation.
Okay.
So, but you don't have a workstation also, desktop computer also, no?
No.
So you still have a choice. Yesterday, actually, I was looking, there is one, like for $300, somebody was selling a very good, powerful laptop with GPU. So that you can buy.
Okay.
Buy a very old laptop with powerful GPU, then job is done.
Okay.
Right?
Yeah, let's play around with your test environment for a little bit. Once we get comfortable, maybe we can go that route.
Yeah.
Just to make sure we can make effective use of that.
Correct. Yeah. And I have 2 servers. I mean, at least one of them I'll give, or if you want, I can swap it also, like remove your user there and add it.
No, that's fine. That's fine. It's not like we are going to do a real time.
Correct. It's no big deal.
Real time setup for anybody. Yeah.
Okay. Anything else?
How do we access this recording? Because of this Ubuntu stuff, I think I can set up something.
My screen? Wait.
Yeah.
See, you go to this website here. Every day after this recording is done, I'm uploading these records here. Last 6 days I've already uploaded, and today whatever I did, I'm going to upload it here.
Oh, okay.
So you can watch all this. It's all in YouTube. Like just click here or expand this one, and then it should play in your browser.
Oh,
you see here?
Nice. Okay. On the Saturday site. Okay.
Yeah, every day I'm uploading the next day.
Okay. Yeah.
Okay.
Thank
you all.
Thank you.
We'll all meet tomorrow.
Thank
Bye
you.
for now.
Thank you. Good night.
See you. Bye.